about exponents, one exponent, or in general, we're talking about exponents. And when we talk about exponents, we talk about a base and a power. So I just want to show you that this 4 stands for the base. We call it the base. And what the base is a factor that I'm going to multiply. Factor does mean multiply. I'm going to multiply repeated times. And how many repeated times depends on this up here. This is called the exponent, or the exponent. And it's written as a superscript, script right, super above. It's written above the number. Later in math, you'll get some subscripts, but that's later on. So it's written above. It's an exponent. And what it does is it tells how many times we're going to multiply base, or how many times we're going to use that factor. So, and the way I would say this is I would say this as I say the base first, base to the blank power. So I would say the name of the base. So I'll put a line here. I say it as some base raised to the blank power, or I would say raised to the blank or just to the blank power. I could put, let me put the word raised in there. So a base raised to the blank power. So in this case, I would say that this is 4 to the 3rd power. Four is my base, 3 is my exponent, so I would say instead, not to the 3 power, we wouldn't say that, but we say it as 1st, 2nd, 3rd, 4th, 5th power, and so forth. So that's how we say it. What it means is it tells me how many times I'm going to multiply my base. So 4 raised to the 3rd power, or 4 to the 3rd power, means 4, I'm going to use that factor 3 times. I'm going to write the number 4 3 times. I'm going to multiply it 3 times. It's a shorthand and it means repeated multiplication. It's a shorthand. It's a symbol for it. Just like if I was going to write 3 plus 3 plus 3, I could write that as 3 times 2. It's a shorthand. Multiplication is a shorthand. And this exponent is a shorthand. Now, because I know this has a value, I can even say what that value is. And how I figure that out is I do 4 times 4, 16, and then times that 4. So altogether, it gets to be 64. 4 to the 3rd power is 64. How did I find that out? Because 4 to the 3rd power means use the base 4, the factor 4, use it 3 times. I have 3 of them. 3 of them. And so I'm going to multiply that. So that's what exponents is. I can use exponents on whole numbers. I can use exponents on fractions. I can use exponents on mixed numbers. So if I had 3/4 and I had that raised to the 2nd power, my base, this would be, I would say it as 3/4 raised to the 2nd power. 3/4 raised. I like that that number's up. It reminds me to use that word raised to the 2nd power. So what does that mean? It means 3/4 times 3/4. I'm going to use that base 2 times. So what that would be 9/16, and that would be 3/4 to the 2nd power. I could use mixed numbers. I can use anything. And all that means is that the base is going to be repeated again and again. And to evaluate it, I would have to find what it is. So I'm looking at an example from your book. It wants to know what would be, let's see. I'm trying to find one a little bit trickier. Oh, it wants to know what 7 to the 4th power is. Well, what does that mean? It means that base 7 is multiplied 4 times. And make sure I write it here 4 times. How do I solve for it? Well, 7 times 7 is 49. And I got another 49 over here. So that's going to be a big number. That's going to be 49 times 49. And I want to find my 49 times 49. That's a big number. That's 2,401. So it's a way to show a really big number with a small shorthand. Okay. Another thing I can do is I can go the other way. Sometimes I might be given something like this. This is right off of the guided practice too. 7 ninths times 7 ninths times 7 ninths. This is getting to be a lot of times I'm writing 7 ninths and I'm getting tired of it. So what would be my shorthand? Well, my base, 7 ninths. And it's important I put the parentheses here because I want to make sure that that goes with the whole 7 ninths and not just with the numerator. How many times do we have it? 1, 2, 3, 4, 5. So a shorter way to write all of this would be 7 ninths to the 5th power. So I can either start with the exponent and put it in expanded form and solve for it, or I can start with an expanded form and make it in a smaller form. Okay. There's a couple of unique exponents you need to be aware of, and that's using something raised to the 0 power. We would say to the 0 power, we wouldn't say to the 0th power. So if I took a base and I raised it to the 0 power, it's 1. Any base raised to the 0 power is 1, whether that's 3/4 to the 0 power or 5,467,000 raised to the 0 power. Any number raised to the 0 power is 1. And so how we write that in algebra, if I say any number that's a letter, raised to the 0 power is 1. That's an important concept to remember. Not just A stands for any number at all, whether it's a mixed number, a whole number, a negative number, a positive number, any kind of number. If that is raised to the 0 power, it is 1. The other thing you want to know is, what if I raise a number to the 1st power? So it's a base raised to the 1st power. And so that just is the same thing as the base. So any number raised to the 1st power is just that number. So again, if I was going to say 3/4, and I'm going to raise that to the 1st power, that's just 3/4. Because if I did it to the 2nd power, I would need 2 of them. 1st power, I only need 1 of them. That's the number itself. I write that saying any number raised to the 1st number is just that number, whatever it was to begin with. Since I'm using the same letter, it means it's the same number. If I didn't know if it was something else, I would change the letter. But if I use the same letter, it means the same number. So that is what we use exponents for. It's a shorthand to get away from writing long things, to make it a little bit shorter, compress our mathematics as we're working through problems. I want to show you something kind of neat on the calculator too. So
I'm not going to put that on. I'm going to stop the recording now.
Okay.